Now example 5.7. A bob of mass m is suspended by a light string of length L as shown in this figure. It is imparted a horizontal velocity v0 at the lowest point A, means here, okay, such that it completes a semicircular trajectory in the vertical plane, with the string becoming slack only on reaching the topmost point C. Means when this bob reaches at point C, the string becomes slack. String becomes slack, it implies that there is no tension in the string. This is shown in figure. Obtain an expression for 1. V0, 2. The speed at point B and C. 3. The ratio of the kinetic energies Kb to Kc at B and C. Comment on the nature of the trajectory of the bob after it reaches the point C. Now see here. First, here consider this position A, the lowermost position, as the reference position. So here we prepare the reference line. So we can say when the object is on the reference line, height that is equal to 0. So at this particular lowermost position, weight of the body mg, that is downward, and tension in the string, that is Ta. When we give horizontal velocity v0 to the object, it starts motion on the circular path having radius equal to L. So here consider position A as reference position. Now we can say at position A, the total energy, that is kinetic energy plus potential energy, it is on the reference position h equal to 0. So potential energy is 0. Its velocity is v0. So kinetic energy, that is Ka, that is half mv0 square. Say that is equation number 1. So total energy at position A, that is half mv0 square. Now consider position C. So when bob reaches at C, suppose its velocity, that is Vc, right? So here again we can say at C the total energy, that is kinetic energy plus potential energy. So here kinetic energy, that is half mvc square, potential energy as per equation mgh, with respect to this reference position, it is at height L plus L 2L. Clear? So we can write the total energy EC, that is equal to half mvc square plus mg into 2L. Now it is given to you when it reaches at C, string becomes slack. It implies that there is no tension in the string. But the force, weight mg, that is towards the center when it reaches at C, right? So here we can say for this circular motion, the required centripetal force when it reaches at C, that is mvc square by r, that is L, that will be provided by the force which one is towards the center, and that is mg. So we can say mvc square by L, that is equal to mg. So mvc square, that is mgl. Now mm will be cancelled. So we can write vc square, that is gl. So vc equal to under root gl. Clear? So here see, the speed at point C is now calculated. Clear? Now if we substitute this particular value of vc square, that is gl here, okay, so we can write ec equal to half m vc square, that is gl, so half mgl plus 2mgl, that is already there, it is as it is. So we can say ec, that is equal to 5 by 2 mgl. This is the equation number 2, and this is the total energy at point C. Now, as per conservation of total energy, we can say total energy that remains constant one. So we can compare equation number 1 and equation number 2. So as per conservation of energy, EA equal to EC. EA that is half mv0 square, EC that is 5 by 2 mgl that we derived earlier. Okay. So now again cancel, 2 cancel. So v0 square that is 5gl and v0 that is under root 5gl. So the horizontal velocity applied to the bob that is also calculated. Now we have to find the velocity or speed at point B. So consider the point B. At point B or at position B again. The total energy that is EB equal to kinetic energy at B KB plus potential energy at B. Kinetic energy. Suppose at position B the speed that is VB. So half mvb square. And when it reaches at B, the height from the reference position that is equal to L. So mgl. Okay. Now total energy conserved. So again here we can write EA that is equal to EB. Okay. Now EA that is half mv0 square, EB that is half mvb square plus mgl. Here v0 square that is 5gl. So v0 square that is equal to vb square plus 2gl. Here 2 is taken common and then here this one is multiplied by 2. Okay. Now see, cancelled, v0 square that is vb square plus 2gl. So v0 square that is 5gl that is vb square plus 2gl. So vb square that is 3gl. So vb that is equal to under root 3gl. So speed at B that is also calculated. Now we have to think about ratio of the kinetic energies at B and C. So let's take kinetic energy at B. So that is half m vb square. Vb square that is equal to 3gl. So half m into 3gl. Then kinetic energy at C. So that is half m vc square. So that is half m vc square equal to half m into gl. Now take ratio kb upon kc that is half m into 3gl upon half m into gl. So this will be 3 raised to 1. Clear to all of you?